My name is Kelsey Jarecki.
I'm Chao.
This is Lab 11, Detectors.
And our TA is Susanna. The purpose of this lab is to determine the characteristics between the photomultiplier tube and the photodiode detectors. And here's the setup. We have the green LED, which is detected by the PD and PMT, and they are connected to two channels on the oscilloscope. And we set up the frequency in about 25 Hertz. When we decrease the current, the signal-noise ratio of PD is about 1. And then we use the cursor from the oscilloscope to measure the peak-to-peak voltage of the signal from PMT. We also use the cursor from the oscilloscope to measure the width of the noise so that we can calculate the signal-noise ratio, which is about 3.6.
So the purpose of this part of the lab is to determine the time constant of photodiodes in various situations. We did this by setting up the stupid flashing fire alarm to go into the detector, which is attached to the oscilloscope. We set the triggering settings to show this nice graph, and then the rise time is the decay time because it's inverted. So for this one, we added a resistor, and it gave us a smaller rise time, which is the time constant, and a smaller peak-to-peak. So with the photoamplifier, rise time is in between the other two, and the peak-to-peak is much larger. So for part C, the setup is the same, but we used the CD photoconductor as the detector, and we found that the peak-to-peak and rise time are both much larger than with the regular detector. But this is the time constants and peak voltages.
Our purpose is to further explore the pyroelectric detector, and here's the setup. We have the chopper in between the source and the detector, and we use the chopper controller to control the speed of the chopper, and we connect the detector to the oscilloscope to measure the peak-to-peak voltage. Here's a plot of the voltage response as a function of chopper speed. With the increase in chopper speed, the voltage response decreases, and it plateaus with a certain chopper speed.
The purpose of this part of the lab was to explore the pyroelectric detector, also known as thermal imaging camera, by using the spherometer to measure the sag of this lens, and then using the calipers to measure the radius of the lens, using that to calculate the focal length, which is 135 millimeters. Then we put this mirror about 135 millimeters away to get in-focus image of soldering iron in the camera. Thermal temperature of the object and the image are about the same.